Hi everyone. This video will show you how to find rotations given the values for sine, cosine, or tangent. Find the rotations that have the given trig value. Sine of theta equals 48/50. A great first step would be to draw the two rotations. I know that for sine of theta to be positive, the y, or in other words, the opposite side, needs to be positive and needs to be pointing upward. So therefore, these triangles have to be in the first and the second quadrants. So I draw my two triangles, and might just be helpful to label both of them. So the y sides are both 48, and the radius of the two triangles is 50. And now I just need to find the reference angle, and then I'll just add or subtract the reference angle appropriately to get the total measure of the rotation. In order to find the reference angle, we'll use our calculator to find the inverse sine of 48/50, and that's approximately 74 degrees. So I can draw the 74-degree reference angle in each of the triangles, and then I just have to figure out the total rotation. For the first quadrant one, since we're rotating off 0 degrees, the rotation is just the same as the reference angle, so 74 degrees. And then for the second quadrant angle, I can go to 180 degrees, and then I'll have to subtract that 74 degrees back to get the rotation. So 180 minus 74 gives me 106 degrees. And therefore, my two rotations, where sine of theta equals 48/50, are 74 degrees and 106 degrees. For our second example, let's use cosine of theta equals negative 0.606. Since cosine is negative, I know that the triangles would need to be to the left of the y-axis, or in quadrants 3 and 4. If I really want to have more specific labels, I know that negative 0.606 is the x-coordinate since we're in the unit circle and the radius is 1. To find the reference angle, I type in my calculator inverse cosine of 0.606. Notice I'm not worrying about the negative sign because I just want the reference angle. And I find from my calculator that the reference angle is 52.7 degrees. And now I just need to finish finding what the rotations would be in the second and third quadrant. For the second quadrant, I know I'm going to 180 degrees, and then I'm going to have to subtract the reference angle. So I subtract 180 degrees minus 52.7 degrees. And so that rotation is 127.3 degrees. For the third quadrant, I know that the reference angle is in addition to 180 degrees that the angle's already traveled. So I'm going to add 52.7 to 180 degrees. And I get that the rotation in the third quadrant is 232.7 degrees. Therefore, my two rotations where cosine of theta equals negative 0.606 are 127.3 degrees and 232.7 degrees. Try these next two on your own. Tangent of theta equals 5/2 and sine of theta equals negative 0.228. Pause the video now and do them before you check it. For tangent of theta equals 5/2, I know that the rotations will lie in the first and the third quadrants since the tangent is positive. And using my calculator, I find that tangent inverse of 5/2 is about 68 degrees, which means that 68 degrees is my reference angle. So the first quadrant angle will be the same as the reference angle, or 68 degrees, and the third quadrant angle will add 68 degrees to 180 degrees to get 248 degrees. Therefore, my two rotations where tangent of theta equals 5/2 are 68 degrees and 248 degrees. For sine of theta equals negative 0.228, I know that since the sine value is negative, my angles are going to be in the third and the fourth quadrant, or pointed down. Using my calculator, I find that the inverse sine of 0.228 is approximately 13.2 degrees. Notice again that when I typed into my calculator with the inverse function, I ignored the negative sign because I just wanted to find the reference angle. Once we have the reference angle, now we just have to finish finding the rotations. Since I'm in the third quadrant, I'm going to add the reference angle to 180 degrees. So 180 plus 13.2 gives me 193.2 degrees for the third quadrant angle. And in the fourth quadrant, I take the reference angle, and since it's all the way around the circle, but then back to the reference angle, we're going to subtract 13.2 degrees from 360 degrees, giving us 346.8 degrees for the fourth quadrant angle. Therefore, my two rotations where sine of theta equals negative 0.228 are 193.2 degrees and 346.8 degrees. So, in conclusion, if we want to find rotations with a given trigonometric value, first we figure out what quadrants the angles lie in. Second, we use an inverse trig function to find the reference angle. And then finally, we just add or subtract the reference angle depending on which quadrant it's in.